All right, good morning and happy Tuesday. I'm planning on doing the Leak Code Daily Challenge for today, the 21st of March. Let me share my screen, and here we go, 21st. And whoa, hold on. I don't want to go back to here where I've solved it already. But yeah, it looks like I've already solved this thing almost a year ago or so. Might as well upload it. Okay, so here we go. It is 9:25 p.m. Definitely getting a later start here. All right. Given an integer nums, return the number of subarrays filled with 0. Okay, so 0, 0, 0. There's one each, and then one of size 2. One each, one of size 2, and one of size 3. One, two, three, 4, 5, 6. 1, 2, 3. So 6 and 3. 3 becomes 6. 2 becomes 3. 1, 0 is 1. 2 adjacent zeros becomes 3. 3 adjacent zeros becomes 6. And then 4 adjacent zeros would be what? What would this be? 1 each, which goes 4. Oops. One of size 2 there. One of size 2 there. One of size 2 there. So there's 3 more. And then one of size 3 there. Oops. One of size 3 there. So there's 2. And then there's one of size 4. All right, so it's the formula is then 4 plus 3 plus 2 plus 1, which equals 10. All right, then for 3, 3 is 3 plus 2 plus 1 equals 6. 2 is 2 plus 1 equals 3. Okay, so we'll just find the runs, right? Here's the game plan, right? Find run length n, then add onto the total t, the sum of the series, the sum of series for n. Okay, there's our game plan, and let's implement it. For x and a, let's see what the values are from negative 1 billion to positive 1 billion. All right, so last equals integer 1 billion plus 1. And then the total, which will return is initially set to 0, return the total in the end here. Okay, and then last, and then to run. Run of zeros. So if not x, actually, how do I want to accumulate the count of zeros then? Right, I want to just use I and j just as a sliding window. That works, right? I, j equals 0, 0. Then n will be the length of a, the cardinality of a. All j is less than n. Or just I is less than n, right? If not a sub I, So actually, let's do this while j equals I. We're only going to use this once. Oops. Let's do this. I equals 0. Well, not a sub j. How about kj? J is less than n. And okay, we do want this a couple times then. I is less than n. J is I. J is less than n and not j. J plus equals 1. The run length then, we just call it n is fine. N equals j minus I. So if it doesn't go anywhere, it's 0, which is fine. I equals j plus 1. Wait a sec. So let's do this. If a sub I, then just simply I plus equals 1 and continue. Otherwise, if it's 0, then we find how big the run length of 0 is. And then I will equal j. Right. We know at least j is I plus 1. How about, so we don't have to skip past the first one. And is this guy, our total equals the sum of the series, which call f of n. Or we're just going to say n times n plus 1 divided by 2 is fine. We can just stick it in here. All right, sum of the series plus equals that guy. And I equals j. Okay, something like that. That looks good. 6, 9, and 0. Okay, that's cool. Oh, right. That's accepted at 9:32. That's 7 minutes for implementation. Implementation in Python 3, which is accepted. Yay. Okay, let's see if we can clean up this code a little bit. Not using last. All right, so we don't need that. There's our total. Let's do this. How about instead of continuing, just move j up and then I equals j if I does not equal j. Otherwise, j plus 1. Yeah, I mean, I don't know. Stick it here. It should be okay, I think. A bit cleaner. Yeah, I don't know. I mean, I commit I at the end here. Yeah, this seems okay. Let's see what we came up with about a year ago on this one. The sum of the series, interesting. Total running sum. Well, this is interesting. You can consider this somewhat of dynamic programming, right? It's a pretty decent solution. different way of thinking about it, but it uses of in memory. One plus the previous. Yeah, those are decent looking solutions. This one's okay too, right? Just the run length and some of the series. Yeah, I'm on the fence for which one's a better solution. I'll just leave these ones as is, I suppose. Right, it's the previous one plus one. Yeah, whatever we can do. Yeah, alternatively, turn, we can use 2 pointers. Right, use a sliding window. Oops, window ij from I inclusive to, right, say from I inclusive to j non-inclusive to find the run lengths, the zero run lengths in, and accumulate the total t via the sum of series, right? Via the sum of series in times in plus one divided by two. And I wonder, well, let's just do these just for practice. Or of one additional memory instead of n. The, I guess, solutions, but right, just different way of looking at it. It's cool to have different perspectives on things, right? Rest. Yeah, it's always cool to solve the same problem in different ways. All right, Python. Okay. These are cool solutions. Oops. Oops, kind of a long T in the end here. Then there's, yeah, should be auto I n equals make pair 0 a dot size while I is less than n, j is equal to I, j is less than n and not a sub j, increment j, n is j minus I, k plus equals the sum of the series for n times n plus 1 divided by 2, then I equals j. If I does not equal j, then it's j, otherwise j plus 1. Just stick it in here too, right? If there's a run length, then it's j, otherwise it's j plus 1. Either way works, right? Yeah, I just might call J might be a little bit more straightforward. That's cool. That should work, right? Doesn't have to be perfect, but it's a different way of looking at things, which is pretty cool. Oh, in is not cool. Needs to be a long. Okay. Should just make this thing a long here. Be auto down here. Okay, that's cool. Let's do JavaScript. T is our total. We'll return here at the end. Initialize to 0. I is less than n, let j equal I. Well, j is less than n, and a sub j is 0. Increment j. N is j minus I, j non-inclusive, I inclusive. T plus equals n times n plus 1 divided by 2. And then I equals, if I does not equal j, otherwise j plus 1. Okie dokie. Looks good. It's cool. Oops. Bam. All right, Kotlin. In so here 0 long and a dot size. Return t, which would be our total. T is long. Well, I is less than n. J is I. Well, j is less than n, and a sub j is equal to 0. Increment j. N is the distance, the cardinality of the run of zeros. E plus equals n times n plus 1 by 2. And then I equals, if I does not equal j, otherwise j plus 1. Ready? Uh-oh. Inferred type is long, but int was expected. Hmm. Does that matter? How strange. Must be an integer instead of a long. This needs to be a long. Okay, I think that should work. Okay, that one's good. And then we'll do rest and then call it a day. Rest. Turn t is our total. Let mute t equals 0 as I64. Let mute I and n equal 0. Usize a dot length. Finalize less than n. Let mute j equals I. Wow, j is less than n, and a sub j is equal to 0, increment j. All right, and then n is j minus I, that's a I64. T is n times n plus 1 divided by 2. And then I equals, if I does not equal j, otherwise j plus 1. Okie dokie. Looks good. All right, that's cool. All right, there we go. Accumulated sums as a recurrence relation based on the run. And then accumulate them at the end there, or we just accumulate the run in total. All right, so you need O of 1 additional n raised to O of n. Right, they're both cool solutions. All right, catch y'all next time.